All right, here's 3 good log questions. All right, so this first question, number 25, it asks to solve for x. So 27 to the x is equal to 10 to the minus 3x. My first thought was, okay, I have to solve for an exponent, see if I can equate the bases. But there's a 27 I can write as 3 cubed, but 10, there's no way I can get that as 3 to the something. So the only way I can do this one is to use the power rule of logarithms. And the way you do that is you would log both sides. So it's the property of logarithmic equality first, and then the power rule. Let me show you. Since there's a base 10 in here, what I'm going to do is take the log base 10 of this side, and I can do that as long as I take the log base 10 of the other side. Okay, so I just log 10 to both sides. Now, when you do that, you can use the power rule to bring that exponent out to the front. So that gets your x in a spot you can get at it. So you have x times the log base 10 of 27 is equal to negative 3x times the log base 10 of 10. Now, if you do log base 10 of 10 on your calculator, that comes out to 1. And 1 times anything is the multiplicative identity rule that doesn't change it. So on the right side, I just wind up with minus 3x. Whereas on the left side, I have x times log base 10 of 27. So I would do that on my calculator, log base 10 of 27. Let me figure that out. Functions log of 27. Okay, I get 1.43. So this would be x times 1.43 is equal to negative 3x, or that's the same thing as 1.43x is equal to negative 3x. I'll get the x's on the same side of the equation, so it'd be 0 is equal to negative 3x minus 1.43x. Maybe I could have put them both on the other side. Or 0 is equal to negative 4.43x. Now to solve for x, I'll divide both sides by negative 4.43, negative 4.43. 0 divided by anything is 0. So my answer for that question would just come out to be x must be equal to 0. Okay, next question. How long will it take a radioactive substance to decay to half of its original amount if it decays according to this function? It's sort of this question is a little bit funny, because you have to sort of look at it in terms of the regular function. So it's P of t is equal to P0 e to the kt. And if it's decaying, your k value will be negative, and that's what theirs is there. So you see how they're the same? And then this stuff and the t. So they're meaning that the 650 is the original amount. So if they say how long does it take to decay to half that original amount, figure out what half of 350 is. And I think it's 325. So 325 is equal to 650 e to the minus 1.29 t. I'll divide both sides by 650 to isolate the e with the exponent in it. So on this side, of course, that'll be a half, as long as I figured that out already. Correct, is equal to e to the minus 1.29 t. Now here you can change it to log form if you want, or you can log both sides. Doesn't matter. I like to change it to log form, but either way is fine. So the exponent, negative 1.29 t, is equal to log base e, that's this e, of 1/2. Okay, to solve for t, I'll figure out log base e is the same as ln. So the ln of 1/2 divided by negative 1.29. Okay, so let me do that on my trusty Desmos. Hopefully that'll work. So I have to go ln of 1/2 divided by negative 1.29. And I'm coming up with 0.537. Does that sound right? That k value is pretty big. Log of a half divided by negative 1.29. I think that's right. So that would be the time that it would take in years for that radioactive substance to decay to half the amount. Fairly big. Okay, last question. Bacterial culture has initial population of 10,000. Population declines to 5,000 8 hours. What will be at the end of 10 hours? This is a double question. So I need to use this first information, start, end, time, to figure out a k value. Once I have the k value, then I can use that k value to answer that question with the 10 hours. All right, so let's write our formula. P of t equals P0 e to the kt. So I'm ending at 5,000, starting it at 10,000. E to the k I don't know, but the time is 8 hours. Divide both sides by 10,000. Yeah, so this side will be a half is equal to e to the k times 8. Change to log form. So k times 8 is equal to log base e of 1/2. So k is equal to the ln of 1/2 divided by 8. Calculator. Okay, ln of a half divided by 8. So I'm getting for my k value negative 0.086643, etc. So my decay function, if I wanted to write it down, would be P of t is equal to P0 e to the negative 0.086643 t. That's the function. So then they say, assume population what will be the population at the end of 10 hours? So they want to know what it's going to be at the end when my time is 10 hours. So the population after 10 hours is going to be, P0 is how many I start with, 10,000. E to the negative 0.086645 times T, which is 10. Okay, equals. So calculator. K and yeah, I'm gonna have to go backwards with this. So e to the negative 0.086645. I wish I could have used that whole number in there. Times 10. Uh-oh. Okay, I think my calculator is okay. So I think that I came up with 4,204.4147-ish. So basically I'll have how many bacteria? I'm going to have about 4,204 bacteria. All right, hopefully that helps you with those 3 log questions. Nice ones.